Okay, welcome to the first video of the second semester of chemistry. We're starting off with Unit 7, talking about chemical reactions. So this is the very first video for Unit 7. It's an introduction to chemical reactions. We're going to talk about how you write out a chemical reaction. So the very first thing we needed to go over is what exactly is a chemical reaction. A chemical change is not always a sign of a chemical reaction. In order for something to be a chemical reaction, you actually have to form or break bonds between chemical substances. So make sure you have the definition written down. So what we're going to be using to talk about chemical reactions are chemical equations, and basically these are things that summarize a chemical reaction. You've seen these before, mainly in the formula format. So for example, that would be H2O. That would be the chemical formula, or you can actually write it down in words. So instead of saying H2O, you would put water. So we're going to look at both formats and going from one to the other in this video. Before we start writing chemical equations, you need to know a few symbols that are used in chemical equations. The first four in the first column are states of matter. So there's actually 4 different states that you need to know of. Obviously, there's solid, liquid, gas. Another word for solid is a precipitate. You're actually going to learn what that is in this unit. Then obviously L is liquid. Gas or vapor, which is just a fancier word for a gas. And then the last one is aqueous. Aqueous is not technically a state of matter. It basically is a solid dissolved in water, and so we designate that with an AQ for aqueous. And then over in the other column, we have our yield signs. Just a typical yield just means that's a reaction. It forms or creates. If you see a triangle over the yield, that means that it was actually heated. If you see a yield that's going in both directions, that means it's a reaction that's actually reversible. And then obviously a yield with pressure written over it is something that is under pressure. So make sure you have all of these copied down because you're going to be seeing these quite often. Okay, so let's do our first example. So this is a word equation, and we're going to translate this into a formula equation. So you just read it, and as you read it, you write it into a chemical equation. It's very simple. So the first example reads, ethanol, which is C2H5OH, is burned in the presence of oxygen and forms carbon dioxide and water vapor. So where you see the word forms, that's going to be your yield sign. You don't always have 2 reactants and 2 products, but this is a typical 2 reactants makes 2 products equation. So it gives us the formula for ethanol, thank goodness, because I'm pretty sure you don't have that memorized. So you write C2H5OH is burned in the presence of oxygen. So that means it's with oxygen. It's another reactant. Oxygen is one of your diatomic elements, so it's not just an O, it's an O2. So that forms, so now you're going to write your yield, carbon dioxide, so that would be CO2, 1 carbon, dioxide being 2 oxygens, and water vapor. Hopefully we know the formula for water, H2O. So now we need to write in the states of matter. Ethanol, if you know or are familiar with, is a liquid at room temperature. Oxygen, that's the gas that you breathe. CO2, that is the gas that you exhale. And then it says water vapor, so we know that this is water in the gas state. And that's all you've got to do. We're going to worry about balancing these starting in the next video, so you can actually leave this as it is. Okay, so our next example reads, solid calcium carbonate is heated and turns into solid calcium oxide and carbon dioxide gas. So before we even bother starting this, you're going to notice that carbonate is a polyatomic ion from your blue sheet. The hardest part of writing out chemical equations is going to be your blue sheet. So you're going to be using this all this week, so make sure that you are familiar with what's on your blue sheet or re-familiarize yourself with that. So solid calcium carbonate, so that means we've got calcium, which is Ca, carbonate is CO3. In order to figure out what the formula for that is, we learned that back in Unit 5. You have to crisscross the charges. This is an ionic compound. It's a metal with a polyatomic. Calcium, if you look on your blue sheet, has a +2. And then carbonate has a -2. So this is actually pretty easy. A 2 and a 2 just get reduced down to a 1 and a 1. So we're lucky on this one. It's just CaCO3. It says it's a solid, so write an S after that. It says it's heated and turns into. So that means this is our only reactant, and it's going to yield solid calcium oxide and carbon dioxide gas. So we're going to write our yields, and if you notice it says that it's heated, so that means you're going to write the little triangle over the top. And calcium oxide would be Ca, obviously for calcium, and O for oxygen. And calcium has a +2, oxygen has a -2, so another easy formula to figure out a 2 and a 2 reduced down to a 1 to 1. It says that it's solid, and so we're just going to write S after that. And then carbon dioxide gas, so CO2 with gas after it. And that's as easy as it is. So when you're doing these problems, you're going to run into a particular issue, and that's knowing what the state of matter of that substance is. Technically, all substances can become a liquid or a gas if you reach higher temperatures. And we're assuming that all of these reactions are occurring at room temperature unless stated otherwise. So how do you know what the state of matter is for a substance if it's at room temperature? Well, there's just a few rules you follow. An element at room temperature, all you have to do is look at the key on the periodic table. They're color-coded based on what state of matter they're in. Most elements are solids. Just a few are liquids and gases at room temperature, so we'll look at that in class tomorrow. If it's an ionic compound, then it's going to mainly be a solid. 99% of them are solids. And so remember that a ionic compound is a metal and a nonmetal. And then if it's covalent, remember that's two nonmetals. If it's covalent, then it kind of just depends on what substance it is. Some of them you're going to be familiar with, and you're going to know, oh, I know that that's a gas at room temperature. Some of them are liquid. So that one's a little more tricky. Usually covalent compounds, it states what state of matter that it's in the problem. Okay, for this video, we have basically summarized it already, so do not worry about writing a summary for this.